Hey guys, Jay here, and I am at the headquarters for HRE Wheels here in Vista, California, and I am with President and CEO, Alan Peltier, and today we're going to be talking about wheels. Might not be something you guys are expecting to see on my channel, but if you follow long enough, you know I'm a huge car enthusiast. I'm also a bit of an HRE enthusiast. And today we're going to take a tour through the facility and show what it takes and what kind of tech is involved to bring some of the most famous wheels in the world to your ride. If you wouldn't mind, just kind of give us a brief history of HRE, where it started,
Sure.
how, and how we got here today.
Okay. Yeah, we've been around a long time. So HRE started in the late 70s, so way before my time, and I've been here 26 years. The story as I know it is HRE was an importer for a Japanese wheel company. And then
that was Hayashi Racing
yeah.
Engineering.
Yeah, exactly. And then started doing its own wheels through the 80s. And then the ownership changed in 93. Our current owner bought the company. And I think that's kind of when they started really focusing on forged wheels. And then new management came in the late 90s. I joined the team in the late 90s as a young engineer.
Well, it's funny because some of my, going all the way back to the year 2000 or 99 with the original Gran Turismo, I had my garage and I had HREs on all of the cars. I mean, it goes back
yeah.
For me, the interest goes back that far, specifically in HRE. And the thing that really stands out to me about HRE is the fact that it is a US-based company, and most of the manufacturing takes place right here in Southern California, which is almost unheard of these days.
People are always like, oh, you should move here and move there. Well, you know, we spend so many years building up our team. It's not so easy for us to just pick up and move to another state.
Right, and you don't even know if it'd work out the same. I mean, your dynamic is here. Like you said, everything you know is here. Speaking of here, here's what we're gonna do today. We're gonna go ahead and start. I actually recently got a newer vehicle, new to me vehicle. Haven't actually showed you guys this yet on the channel. If you follow on Instagram, you've kind of seen some teasers there. But of course, the first thing I did when I got that car was hit up the guys here at HRE and say, here's the new car I got. I have HREs and everything else. I need a set of wheels for this, but I don't know what I want. So obviously the sales team helped me quite a bit with deciding what kind of wheel.
And we're good at that, right? And so sometimes people look at our portfolio and go, gosh, I don't know, there's so many choices. And really it's just pick up the phone and call us and ask us, because we have an opinion. We see these cars all day.
And chances are, whatever car it is, you've done something for that model already.
And we have, even if we haven't, if it's a new car, we still have a sense, when we're designing wheels, we have certain vehicles in mind. And so we're gonna try and pick a wheel for you, or steer you in the direction, not pick one for you, but steer you in the direction of something that's going to look good, because we have a good sense for what's going to look good.
Well, your guys are incredibly patient, because I went back and forth for weeks, weeks. I had a harder time choosing wheels for this vehicle than I did any of the other ones.
Yeah.
So let's do this. Let's go ahead and we'll assume the order came in, right? So we'll pick it up from there. Let's head over to the design area and let's see what goes into creating the wheel, because with the exception of the flow-form wheels, everything is basically bespoke, made to order. Okay, let's go take a look at the design team. Let's talk about the computers and the tech that's needed to go into these CAD designs.
Okay.
So now we're in the design center here, basically where you guys have engineers on hand for every one of these orders that come in to make sure that load characteristics are correct, strength.
So the way it works is we're going to check fitment, obviously. So all of that, those specifications, make sure the vehicle and the wheel specs are all good. So we do double check fitment. But we have some standards, so we don't have to check every one. So when we create a wheel, we have a certain market, and we're going to have certain load ratings of each of that style, different variations of it.
And that's why the catalog is very transparent too. If this is for an SUV, you have to have SUV load rating.
And if you try to buy a style from us that isn't SUV rated, then we won't sell it to you, or we will go ahead and make a version of it that is. That happens as well. When you're an engineer, you learn solid modeling, and that's kind of where you have a solid and you cut out pretty basic shapes and subtract. It's very similar to machining.
Right.
But when you start to create these, can you highlight some of those complex surfaces? That's called surface modeling, and it's a little bit different. And what you have to do,
and I want to say this is moving around very smoothly. Real quick before you move on, what are the specs to run this? You're like, fast? It's fast. What had to be adjusted on my wheel? I guess not much had to change.
The load rating was already there. Okay. So what we're going to change is the back pad height. the hub bore diameter, because that has to be very precise.
66.6, what I believe mine was. Yeah,
has to be very precise.
Yeah, because people think that, oh, the lugs just hold the wheel on. No, the hub holds
centers
the wheel.
Yeah.
And then the wheel has to rest on the hub. You don't want the lugs taking the load. It should be the hub.
The lugs are only holding the wheel against the hub.
Yeah.
They're not centering the wheel or anything like that.
They should not be. Yeah, I've heard this term before. Oh, these are lug centric. That's
old school.
Yes.
Very, very old school.
No. And then you see these people that will just buy a wheel like, oh, it fits because it has the right bolt pattern.
Right.
But then they're dealing with a hub on the wheel that's big, or the bore is bigger on the wheel than it is on the hub, and it's just being held on by the lugs at this point.
Exactly. And you're going to have vibrations and all kinds of other problems.
And eventually broken studs, and then a wheel passing you on the highway.
Exactly. So when we're designing, what we're going to do is iteratively throughout the process, as he's making tweaks to his design, he's also going to be running what we call FEA, finite element analysis. And that's where we're putting in a load condition. There's a couple different load conditions that we put in.
Can you give me an example of a load condition?
It's the main one for high performance wheels is a cornering. It's called a cornering load. Okay. And what it is it's on a test rig. It's a fatigue test. And so what we do is you're bolting down the wheel and you're putting a big beam on it, and you're bending the beam, and then you're rotating the wheel while the bending stays in one direction. What that does is it makes the wheel basically get bent as if it's going around a corner. And what we're running is a high cycle fatigue test. And what we're doing is we're going to simulate that test in FEA to do a structural analysis of it, to see where the wheel is strong, see where it's weak, see where we can take out any mass, see where we need to add mass or stiffness. And we do all of that in the computer before we're ever going to cut a prototype or send it out for testing.
So where we see this gradient here from blue towards red, this is showing where the stresses are?
Yes, exactly. So if it was red, so right now we're well below our maximum. So right now that wheel tells me, we've already finished this, right? This is a wheel we've had for a while, so it's clearly designed to be strong. But let's say we're halfway through the process, we might see this. And then what we would do is we would adjust the dimensions to get rid of that red, right? Because that's where the high stresses are.
How come it only shows it on one spoke versus?
Because it's only simulating in the one when you're.
Oh, gotcha. So the weight right now is going down on that one.
Exactly. So we're analyzing the worst load condition, which would be if the spokes were down, actually.
Okay. So that's showing what the torsion would look like on it. That's how the
highly exaggerated.
I would hope the wheel's not doing that. rubber wheels. That's
you're not going to be able to. You're not going to be able to see it, right?
But that's just showing the rotation of that load.
Yes.
Right.
Exactly.
So as the wheel's rotating,
it's going to see that kind of bending.
Okay. Exactly. So that's that torsion load right
And there is another, so you notice the barrel is dark blue, so there's not a lot of any stress in the barrel. That's because this load condition really is stressing the spokes.
Yeah.
And so there is another load condition where you're just pushing straight down on the wheel and you have it on a tire and on a big drum, and that will put a lot more stress on the barrel.
And that'd be more like potholes and things like that.
It's really, the worst load condition there is really like towing.
There is a variant of my vehicle that has a wider rear tire. And I've heard of people fitting as wide as 345s in the back, but I chose not to do that because one, we start going to a gray area we're not familiar with, and it's a four-wheel steering car.
Yeah.
So I needed to make sure we weren't going to have issues there, because now we're dealing with a wider offset and rear scrubbing now.
We're starting to see a lot of that. So with modern cars, a couple of things that are changing. One, the offsets are getting really high. So wheels that used to have a lot of shape are all getting very flat. And a lot of that has to do with packaging, and then a lot of them now have rear steering. And so that rear steering stuff has to go somewhere. And so it's pushing the wheels out. And so it's making wheels, it's constraining us on the styling side for sure, because they look nicer when they have more three-dimensional shape. But we can only do with, we can only work with what the cars give us, so.
Okay, so the orders come in, we've gone through design. Design now gives it signs off on it, and it moves into manufacturing. So let's go take a look at what that raw material looks like, and then we'll follow that through the machine shop. So we'll talk about monoblock first, because you guys offer monoblock, which is a single piece of aluminum turned into a wheel, FMR, which is your two-piece technology, and then three-piece, obviously, which is not quite as popular these days. So these forgings, tell us about these, because obviously we have some flat ones here, and we have some concave ones. How does this turn into a wheel?
Well, first, to get to this, basically it starts as a piece of billet, and then it gets pressed into a big mushroom shape. And it doesn't actually have the barrel on it. It's still got a short skirt. And what you have to do at that point is, it's called flow forming, and you take the barrel and it's spinning on a mandrel, and you squeeze it out, and then you get that length. But what you've done is you've really refined that crystalline structure, that grain structure of the aluminum, and that's made that barrel a lot stronger. So that happens on one-piece forged and also on our cast flow form wheels. The barrels on the cast flow form wheels are also flow form.
Now you guys call them forgings. I kind of refer to them as a blank, but you have a bunch of different sizes.
We actually call
here.
them blank forgings, yeah.
Yeah, okay, so there we go, we'll meet in the middle. But you have a bunch of different sizes and widths and diameters. That way you're not wasting a lot of material, and allows you to load it up into the machinery to turn a product much quicker.
Obviously, you have to have different diameters. You have different profiles, like you mentioned. This is a high offset one.
What's the biggest wheel you have made so far?
We have a 24 by, I don't know the width, but 24
so
is the largest
that'd be
diameter.
Obviously an SUV then, because I know my wife's car has a 24-inch wheel on
exactly,
it.
Exactly.
So my wheels started out like this then?
Absolutely.
Right? So from here, where does it go?
To the lathes, and that's where we're going to cut the profiles.
All right, let's go check out the lathe.
All right.
Okay, so it's loud out here. We're trying to speak up, but during the process, I got an email that said, hey, good news, your wheels just left design and have now gone out to the machine shop. So basically that's this step, right?
Yes.
They pick the forging blank, or the forging blanks, right?
Yep.
Okay, that's the right size for my wheel. They come over here, they get staged, and then they make their way onto the lathe. Now these haven't been touched yet. You can see just how thick the material is. So walk me through what the lathes are doing real quick, because obviously they're doing two different things, right?
Yes. So the very first one is basically going to cut. It's oriented this way. It's going to cut the inside of the wheel, not the face of the wheel, but the inside barrel. It's going to thin everything out to get the right specifications, make sure the bead seat for the tire and everything is all to specification. And once that step is done, it's going to basically get flipped over, and it's going to flip into this lathe. And at this point, it's going to cut the rest of the outside
So
barrel.
now the face is facing up.
This one's facing up, and then it's going to cut the face in the profile that we want for that particular style.
Okay. I think it's neat that you guys start with these forgings like this, because my question was always, man, how do you limit the waste, right? But like you said, because they're already sort of like formed out, there's a lot of material there's a lot of efficiency in doing it that way.
It's been the barrel's been flow formed out. We're not definitely cut. I mean, there are times when we cut from a solid chunk, go billet for special projects for some of our OE customers.
Now, right now we have a really neat, smoothie looking wheel. But obviously it still weighs a ton.
Yes, because it's solid.
So where does it go from here?
From here it goes to the mills, and that's where we're going to cut the style.
So this, as a nerd, this is the cool stuff. I love watching it move like this. A lot of people don't know this. For one summer, I worked in a machine shop back in my early 20s. I learned a few things. One, you don't stay clean.
No.
Two, you never wipe the chips with your hand. I got some nice cuts from that. And three, it's just neat watching something go from raw to a cool design. So this lathe is a 3-axis, you said.
Yeah.
So the head moves and the platform moves.
Yeah.
And you can load these up in pairs.
Right. Unlike the horizontal mills for one piece, which cut horizontally, this is more traditional. It cuts vertically. Now, we do have to flip it over when we cut one side of it, and then we have to manually flip it over and cut the back side. But we do have it set up in pairs, because 2 fronts, 2 rears, so it works really well. So basically it's gonna run the program, cut the face, shift over, cut the face, and then they'll flip them over, and it'll cut the back on both of them as well.
It almost looks polished already, and it hasn't even touched a tumbler yet.
Exactly. And that's why these more complex designs like that take a long time.
A design like that, how many hours do you think this is on the machine?
On something like this is probably 3 to 4 hours.
Okay. Yeah. So we know it'll be here at least that much longer, because it's got a whole nother one to do.
And then we have some, the simple ones that are straight cut. Those can be cut in an hour or less. And then we have some of our more complex, big luxury wheels that are big 24s that have a lot of surfacing. It can be more like 10 hours.
Let's say it's done in the mill, it comes out, what's next?
So it'll go to QC, but after that it's gonna go to the prep. So there's multiple steps. If it's just gonna get like a black or something, it's gonna get tumbled.
Okay.
But if it's gonna get polished or hand brushed, if it goes into hand brush, then they're gonna do a lot of work by hand.
Okay, so once it's done on the lathe, it comes over here to what you call the cell system.
Yeah.
And this is really neat. So why don't you walk us through it?
So what this is we have 5 horizontal mills. And by horizontal mill, I mean it cuts this way versus the traditional mills which you'll see for 3-piece cut vertically. So these cut this way. They have a 4th axis. They can spin around and they can cut the back. And then it can turn at an angle and cut the valve stem. And then it's done. But what's really neat is the robotic cell system that feeds them. So what we have is 2 loading stations here. We'll load those blanks off the lathe into this robot. There's 20, 30 different stations. It will basically store them until the mills are done. And when the mill's done, it'll basically unload the mill, store it for us to remove, and then put a new blank in, and it'll keep cutting. So when we're really busy, like on a Friday, we'll load this thing up.
Oh, so it goes all weekend.
And it goes all weekend. And it'll come in, it probes to make sure we put the right part in. It knows what it's expecting to see, right? So it'll probe, as long as it's seeing everything, it'll go ahead and cut it. It'll check to make sure no tools break or anything like that.
Does it do auto tool switching too?
All the mills do that.
Oh,
but
okay.
It actually probes after each tool is cut to make sure nothing has broken. Otherwise it stops. That way it stops to make sure we don't break a bunch of tools and things like that. So there's a lot of error checking. But what's really neat is before, all the wheels that come out that go through it are different. So you can put 40 different wheels in, and they all come out and they're all different sizes, all different styles and all that.
So it knows when you load the wheel and you load the job or whatever, it knows what it is, and that just sticks with that cartridge or whatever you call it.
Exactly.
And then, so once it's loaded in the machine knows this is the program I'm executing, and off it goes.
When we combine those specs before, I was talking about the fitment and the wheel specification, that gets put on a traveler. And when it gets to this step, they just barcode scan it, and then they assign it to that station. And so all the specifications from the barcode go into the mill, so the mill knows exactly what it's supposed to do.
Now the cool thing is you were saying it can park them. So obviously the different wheels and how detailed they are take different lengths of time to go through the mill.
Yeah.
So if let's say one takes 15 hours and one takes 4 hours, and it's during the night, what does it do with the ones it's done with first? They just kind of get queued up somewhere?
Exactly, they just get stored.
Okay.
And then when we come in on Monday morning, then we'll unload them. Like this wheel right here is waiting to be unloaded from the station.
It actually allows you to almost have 3 shifts worth working right here.
That's exactly right.
But without having to actually have a man here manning it all night long, 24 hours a day.
Yeah, exactly.
Because they should be running 24 hours a day then.
And they can run 24/7.
Okay.
Exactly. That's
now,
exactly right.
What you can't see in this shot is the sheer scale of this robot, we'll call it, nearly the length of this shop. It is very cool.
It's a big investment. For sure.
Yeah. So let's go take a look at a 2-piece of the forgings for the face.
Forgings for the center, exactly. Yep.
All right, so now we're talking about the 2-piece wheels. This is the forging for the center.
Yep.
Right, so it goes into a very similar lathe, I assume.
It's exactly the same equipment, but it's different fixturing because it's a different type of part, right?
Okay.
So the fixturing to hold the part is different, but yes, the lathes are identical. And so the first step on this one is actually reversed. We're going to cut the face on the first step, and then in the second lathe, we're going to flip it over, and then we're going to cut the backside. So that is actually reversed from one piece, but
so it's the same
still
thing
a two-process step.
The lathe provides the profiling, and then when you flip it over, is that then start doing the hub?
Yes, exactly.
And then from there, it goes into mills, just like the monoblock, to do the design. This is now like part of the prep. So depending on the color of the wheel, gets different types of prep. So we'll look right here. These are the polishers or the tumblers, which has abrasive media, which is actually doing the polishing.
Yes.
So tell me why there's 2 different types. Like we got these conical pieces, and then you got very fine ceramic like bearings over there. So
if you're getting an opaque, like a black or a silver, it's actually going to go through just the single step, and it comes out with a kind of a mottled finish.
Does that help just get rid of some of the rough machine marks?
Exactly. Okay. Any of the sharp edges or anything. We get most of the machine lines out in the programming, but it gets rid of any sharp edges, and it gives a nice consistent surface for powder coating. But if you're going to get a high polish finish, then it has to go through another intermediate step for a couple hours here, which is a
It's very soft.
Ceramic, yeah.
It's very smooth.
But it's not that hard.
Right.
But then if you come over here,
so that's okay.
Yeah, that's an intermediate. This uses a very high hardness ceramic.
I see.
And that's how you get to the high polish.
Okay, so it goes from, if it's a dark color like you were saying, it goes in the first pass.
Yep.
Then this is like stage 2, and then this is like stage 3 of the polishing,
Exactly.
where you get that mirror finish.
Exactly.
Okay.
And then the other thing we also offer is a hand brush. That's in the room over there. It's a little loud.
That's what my wheel got.
Right, and that's a little loud to show you at the moment.
I didn't realize
And
that was done by hand.
It's all. We don't want it to be done by a machine. The wheels are complex, so you want to be able to get into all
follow
those
the curve.
little areas.
Yeah.
And it also adds a little bit of variation so that when you see it, it has a little bit of extra pop to it, and also you can tell it was done by hand.
Right.
So it's nice.
Tell me about the fluid here.
That's just like a light soap and water.
Oh, okay.
Yeah.
All right. So that's just to give it some lubrication.
Exactly.
So it doesn't
Exactly.
cause scratches and more. It's just
Exactly.
It's insane how polished this comes out. Like, we all know hand school buffers and stuff, or old school hand buffers, but the product when it comes out of here it's perfect.
What's really nice about it is, in the old days we used to hand polish, but as the designs have gotten more complex over the years, the hand polishing ruins all that fine detail.
Right.
And so this allows us to create a very high polish, but maintain all that detail that the engineering team spent so much time putting into the wheel.
So I think that naturally takes us to the finishing step, because the audience might be saying, why would you brush it if you're just going to powder coat on top of it? But that's where the frozen, which is what my wheels are, is very unique.
So when you're doing so you think of a brushed and clear, it's got a clear coat on it. But we have a lot of tinted clears. So you can get a tinted bronze, you can get a tinted gold, blue, red, but it's translucent, so you can see the brush coming through.
And I know you guys haven't seen it yet, I keep teasing it, but that is exactly what mine is.
And then when you put the frozen, so you have frozen, what we do after that is put a satin over the top of it, and that gives it that frozen look.
Right.
Really nice.
All right, so let's go check out the powder coating and the finishing process.
Yep.
Okay, so now we're in the furnace, basically. So if I say it feels like a furnace, because we're in the room right now where they do all the powder coating and all the ovens to do the baking of the powder coating. But for those who don't know, powder coating is actually like an electro.
It's a fine plastic that's electrostatically charged.
Right.
Clings to the
So when they're applying it, the electricity draws it to
Yep.
the positive and negative ions. They pull to each other and you get a nice even coat.
Exactly.
But you could wipe that powder right off if you don't bake it onto the wheel. So that's what the ovens are for. Now, we talked about the frozen. I've never really seen anything like that before until HRE. So tell me how you guys came up with the frozen concept and what that actually means.
So the way that works is what we do is if we have a translucent clear, let's say a translucent gold or something, we'll shoot it and it'll have it looks like a normal clear coat, but just with a tint. And then what we'll do is we'll go back with a satin clear coat and we'll shoot over that, and that gives it that frozen and makes
depth.
That depth.
Yeah.
That's exactly the word I was going to say, depth.
I want to put this out there because I mentioned earlier that I got that email that said, hey, your wheels have made it into the machine shop. And then I got another email that basically said, okay, your wheels are done in the machine shop. They're now going to finish and then QC.
Yeah.
And there was a delay in my set because it didn't meet a standard. Two of the wheels didn't meet a standard that was expected to be met specifically with those frozen. So I'm assuming with the frozen, it's harder to get that exactly as you want versus just a solid color.
For sure.
So I appreciated the fact that it was, hey, we're going to strip those wheels, we're going to do it again because it didn't meet our standard.
Yeah, that's one thing that's really challenging with custom wheels is you spend a lot of time doing all of this complex machining and all of this hand prep. But at the end of the day, that final finish, that final clear coat that goes on it has to be perfect as well, or you've ruined the whole thing.
Yeah.
And so, we're going to touch up where we can. That's done out here. We're going to touch up, and if for some reason we're not able to touch it up, then we'll strip it and redo it.
Okay, so let's see what the final steps look like.
All right.
So now here we are in, what would you call, what's this area called?
This is assembly.
Assembly, okay, so we got a 2-piece wheel that's going together right here.
So 1 piece and all of our 2-piece and 3-piece obviously go through touch-up. And then 1 piece at that point are gonna get actually a finished inspection at that step and then go to assembly, shipping.
Okay.
But for assembly here, they're gonna bring the center, they're gonna inspect it again, and then mate it with the barrel. One thing is, these fasteners are structural. They're holding the wheel together.
Right.
A lot of people think they're rivets that are just decorative or something like that, but they're not.
Well, because there's a lot of fake ones out there.
Yeah, exactly. Yeah. This is actually a high-strength stainless steel fastener from ARP. So ARP,
It's not gonna rust, it's not gonna discolor.
And so they don't fatigue. These are amazing.
With my FMRs that are on my RS6, there was obviously a message that said, do not take the wheel apart for any reason. HRE should be the only one taking it apart. It's a pretty bold design right here. This is just like a fire engine red with a polished barrel.
Red is not very typical for us, so it's pretty...
I thought the same thing when I walked by the other one,
The timing to come out here and see him putting together a red wheel
is very bold. Everyone knows the most important step in painting is the prep.
100%.
The same as for powder coat.
Exactly.
So
that's exactly right.
Well, I know from here it goes to packaging, which is kind of a boring step, but it's an important one because they have to arrive with the delicate and loving touch. Like, I used to be a FedEx ground contractor.
Yeah.
It's just a box to the driver.
Yeah.
But to the person on the other end, it is a very big investment into their vehicle.
Our packaging for our forged wheels is rather intense, but there's a lot of cost that goes into the wheel, and 40% of our business is shipped overseas. So we don't want to ship something all the way across the world and have it get damaged. Right. And so, our packaging on our forged wheels in particular is kind of insane.
Every time I've unboxed mine, it's like a kid at Christmas time. You cut the tape, you pop the staples because they overlap. The box lids overlap. They don't just touch in the middle, but they do overlap. They're stapled, they're taped. Then you've got the foam on top and bottom, the closed cell foam. Then you have, like, you see the tape and stuff that's there, but on top of that, you have like a bag over the wheel. Yeah.
A lot of our customers don't open up the boxes themselves. It's a dealer doing it. But if a customer does open the box themselves, we want it to be a nice experience.
Look, my neighbor, when my 207s arrived, my neighbor was driving by. He's another car guy like me. And I literally was doing the Lion King thing because I was looking at it in the sun. So he saw me in the driveway. I'm looking at my wheel like this. He's like, what is it, Simba? I think it's time that we reveal the car and the wheel.
Absolutely. Let's go check it out.
Okay. And this is my 2020 AMG GTR. I've wanted this car for a while, actually. It's a track monster. You guys know I love to track my vehicles. And obviously this is featuring the HRE P207 monoblock wheel that just went through everything that you guys just saw. So we all the way back to the design process when we talked about the smooth edges and stuff. Yeah. I feel like the 207, and I call it 207 instead of just P207 because it's available in multi-piece FMR as well, which is S207. Yeah. But I feel like the split spoke design for me always says muscle car. To me, this is a German muscle car built for the track. It's got the split spoke, but it's that smooth swoop into the lip that I think brings out the body lines in this car.
I think the 207 is a great fit for this car because you're right. That split 5-spoke is typically, we're thinking of a muscular 2-door, right? And so that's usually where we're going with a 5-spoke split. But you're talking about that complex surfacing. Yeah. That really highlights the beautiful curves.
The way it catches
of
the light.
GTR. And it's like, you see those reflections, right? Yeah. That gorgeous surfacing, you see those reflections, particularly with the frozen. That's why we really like the frozen versus the gloss. The gloss, everything, all the details get lost.
It kind of gets lost in the reflection.
It really does. Yeah. And so with the frozen, it really highlights the machining and the design.
I have a new appreciation now for those smooth edges, what it takes to do that. I'm real particular with the style of wheel, and it took me a while to figure this one out, but obviously your team helped quite a bit in helping me make the right choice. Your gallery on your website is hugely helpful because there's very few cars you can put in there and you guys haven't done a photo shoot with. So you get ideas, not just in the styles, but the colors. And,
And actually, if you actually are still struggling, we can do renders.
Yeah.
And so we can do very high quality renders, not just a sloppy little Photoshop, like really nice render.
well, and one of the things that unfortunately we don't get here indoors is the way that the wheel looks when the sun hits it with the frozen brushed. But outside, when the sun hits this, it goes more saturation. It has like it's a bronze color, but it has more of an orange, kind of a coppery color to it.
For sure.
And that's probably some of that bare aluminum shining back through.
It is, and it's a combination of that brush and the aluminum, and that's that depth we were talking about before. That really starts to come out in the different lights.
Well, thank you so much for allowing us to take this tour and see what it takes to take what appears to be just a chunk of aluminum and turn it into a wheel. I think most people would have to agree there's way more involved in not just creating an awesome style, but a safe wheel.
Yeah, it has to work, it has to perform, but it has to be beautiful too, right?
Yeah.
And so that's our mission. Yeah.
All right, guys. Well, thanks for watching. I hope you guys have enjoyed this tour. I've never really done anything like this before, but it was a lot of fun, and it all starts with the computers. All right, guys. Thanks for watching. As always, we'll see you in the next one.